So this is going on page 94 when we're done. So you have two pieces of paper in front of you. We're starting with the one that doesn't say continued right here and starts with previously up here so that you're looking at the right page. Okay, so previously, the Thursday before spring break, we learned how to identify the midline, amplitude, and period from the graph of a sinusoidal function. All right, so does sinusoidal include cosine also? Yes. Sinusoidal is sine and cosine, because remember, you can just shift one of them to the left or right to make it into the other one, right? So they do, let's count as both. All right, so we are going to look at these sinusoidal functions with transformations. Now, the transformations, same transformations you've been doing for years, okay? They have some different names when we start graphing trig stuff, but it doesn't mean that they work any differently. We're going to start by drawing a little sinusoidal curve over here. It's okay that it's not perfect. Mine definitely is not perfect, but I just want to be able to refer to something here. And it's fine, just make a little squiggle over there. It'll be good enough for what we're doing right now. When I draw this in, right, that's called the midline. Midline of a sinusoidal function, it's in the middle. So as far as the transformation is concerned, all this is a vertical translation. It's just a vertical translation. For the parent functions, the midline's at y equals 0. And then if we shift up or down, that midline just goes with it, kind of like an asymptote did, right? And it's just kind of an important part of that graph. All right, so then we have the amplitude. Amplitude is the distance between and the max or minimum points. For a parent function of sine or cosine, do you remember what the amplitude is? What's the biggest sine value you can give me? What? Oh, I thought. What's the smallest sine value you can give me? Think about your unit circle. What's the biggest sine value you got? 0 is not the biggest or the smallest. It's not the smallest yet. Those are angles, the values. If I ask you for the sine of this and that, what's this number up here and right here? On the unit circle, it's 1. Yeah. So I can only, the biggest sine value you can give me is 1. The smallest one is -1. Right? So the amplitude of the parent function is just 1. If I'm going to change the amplitude of my graph, it's going to be a vertical stretch or compression, which makes this a vertical dilation. Okay. Then the period is the x interval that is, bless you, well, not the x interval, but the distance that makes one cycle or one, bless you, or one rotation of a motor or something, right? So the period, what's going to change the period is if we stretch or compress it horizontally. So this is the result of a horizontal dilation. So we've talked about horizontal and vertical dilations and the vertical translation. Horizontal translation is going to come in just a little bit, but we're going to do that kind of separately. All right, but that's how those names of those things that we have learned work with your transformations. Okay, so let's look at these equations. We have f of theta equals a times the sine of b theta plus d. Now, we're using theta instead of x, but those could also be x's, and that'd be fine. Same thing. And then k of theta equals this right here. Right? And then we'll have the following transformations. So just like in everything you have done, all of the transformations you have done, the a's are your vertical stretch or compression. It's your vertical dilation. So your vertical dilation, absolute value of a. Okay, that's the factor of the absolute value of a is your vertical dilation. And that goes along with the amplitude, so that is the absolute value of a. Now, a can be negative. If I have a negative a, if I had a negative in front of there, what does that negative do to your graph? It flips it. What's your mathy word for flip? Reflects. Good. It's a reflection across which axis? Which axis? X. Very good. A reflection across X. So we say amplitude is positive. So if this was like -5 sine of blah, 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 your amplitude is 5. Your A value would be a -5, okay? Because you'd have an amplitude of 5 with the reflection. There's like two things there together. So your amplitude is always positive, but your A value can be negative, and that just includes a reflection, okay? So just be careful with like which thing you might be being asked for. All right, so then our vertical translation, just like it has been before, that's your shift up and down. That's D, not absolute value, because the sign on that tells you if you're going up or down, right? And since this is a mid-line, keyword being line, y equals D represents the midline of the graph. Then a horizontal dilation, right? That's where B comes in, just like it has before. And just like we've known forever, what do we know about X? What is he? A liar. In this case, we have theta. It's just the independent variable. So in this case, theta is a liar, which again could be X or whatever your independent variable is, still a liar. So it's not by a factor of B, it's by a factor of the absolute value of 1 over B, just like it always has been. Again, the way these things work, none of it changes. Okay? Now then we need the period. So the period is not B or 1 over B, but we use that to find the period. What is the period for the parent function? I have, let's just use sine. One cycle of sine takes me from 0 to where? 2 pi. You got to go all the way around the circle. 2 pi. So to find the period, we're going to take the absolute value of 2 pi divided by B. Now, sometimes we have the equation, so we know what B is and we need the period. Sometimes we have the period and we need B because we're trying to write the equation. It depends on which direction you're going. So this, we can also look at this as if I need B, that's equal to 2 pi divided by the period. So basically 2 pi divided by one of them gives you the other one every time. Okay? So instead of thinking about it as two equations, just 2 pi divided by 1 gives you the other. Everybody good so far? All right, so this stuff you have to practice. You have to do your assignments. I know a lot of you do. I know some of you don't, or you put them off. If you have not even looked at the stuff that we did before Thanksgiving, I almost said Christmas, so I changed it to Thanksgiving. Good Lord, no. I won't go back that far. Before spring break, then you might be a little confused today. And if you don't even try and do these assignments, you will be confused. All right, so ask questions, do your assignments, because you need practice. That doesn't mean that this stuff is any harder. It's just that, like when we did logs, you've seen logs before. They weren't brand new to you, right? We might have had some new stuff, but they weren't brand new. This stuff is all brand new to you. Now, the transformations, again, they're just the transformations. But these trig graphs, they're different. And because they're different, you're going to need practice, and you will get better at it and feel better about it, okay? All right, so let's look at this. I did. This recorder is different and weird, but thank you. And I think that it's, no, but I appreciate that because I have done that before. It has stopped or I've accidentally touched it, and yeah. I know. Hopefully I don't have to use this one for very long. Okay, so the graph of the sinusoidal function h is shown in the figure above, along with the information about the amplitude, midline, and period about the graph. This function can be written as, now you're going to see this kind of thing a lot, where they give you the generic version, and it's a really good thing for a couple of reasons. Because there is an infinite amount of equations that I could write for this function. And I could write them as cosine or as sine, just depending on how I write them. And I could write them with reflections or not with reflections. So having stuff like that kind of tells me what my goal is. Now, whether it's sine or cosine, it's not going to affect my answers for A, B, and D here. But I do want to remind you that for sine theta, your parent function and what you need in the picture you need in your brain and to maybe sketch out sometimes is that. And for cosine theta, it looks, well, that's really bad. It's okay, they don't have to be beautiful, but okay, well, something like that, but a whole lot better. But again, just the general shape and basically where it, quote, starts and stops. It doesn't really start and stop, but the first positive cycle in a parent function, you can think of it like this. All right, so with that, when I look at this on any of these graphs, the first thing that I would do always is to sketch in the midline, which I know is already sketched in for me, but because that kind of helps me center the graph. Remember, that becomes my new x-axis, okay? And so since this is my new x-axis, it's my midline, the amplitude is the distance here between these, right? So if this is 3 and I go to 9, or 3 and I go to -3, either way, that distance right there is 6. That's what makes my amplitude 6, okay? Then, so I guess I can write down my amplitude is 6. So A equals 6. The next thing I can find is, now I can find my period a couple of different ways. I can start here. I can look at this as sine, and I go from 0 to pi, which makes the period pi. Would you agree with that? Okay. Now, I also could start here and here and look at this as cosine, and my period is still pi. I don't think it's as easy to figure out, especially on this graph, because I'm not 100% sure where those points are without thinking a little harder. So probably isn't the best, but it could be a cosine graph as well, right? But that is still pi. Or I could start here at pi halves and go to 3 pi halves, and that is still pi. But you can always, whatever's the easiest for you to figure out, whether it's sine or cosine, still going to be the period. So the period here is pi. Everybody okay with why it's pi? All right, now, that's not actually something they asked me for. They asked me for b, but I need this, right? And so b, to find b, I'm going to take 2 pi and do what with it? Divide it by pi, and that gives me 2. Okay? Everybody good so far? Yes, for sine and cosine, because that is the period of the parent function. That's why we're using that. So the numerator will be to 2 pi, whether I'm looking for b or the period. Yes. Okay, everybody good with that? All right, and so then here is the midline, right? Y equals 3, because it's a line, but that means that d is equal to 3. And that's it. Okay. It's just the same letters that have been in every transformation we've done. Yeah, transformation letter. You could use P, Q, R, and S. Sometimes H and K is in there. You might have used H and K in the past. It really doesn't matter what the letters are. It's where they are. And so that's why instead of they don't just ask you this, they give you this and ask you that so that you know where they are. But yeah, they should be the same every time. Okay, we good? All right. All right, so this one is to write an expression for f of theta, but it doesn't tell me, like it doesn't give me that generic one here. It just says write it. I could write it as sine or cosine. However, we have not talked about shifting left or right yet, so that kind of, limits our options. So I'm going to draw in my midline. And since we can't shift left or right yet, then if I start here and go through one cycle, is this sine or cosine? Sine. So this is a sine theta graph, right? Then in order for me to write these things, I have to find A, B, C, and D, except we're not to C yet. So let's talk about A. A is the amplitude. What is the amplitude here? 3, okay? Then I need B, which means I know I'm going to take 2 pi and divide it by the period, which is pi again, because I start here and end here, right? So 2 pi divided by pi gives me 2. Yes, because my equation, once again, is y equals 3, so d equals 3. Okay, so I have all my pieces. So then I just got to put my pieces together. F of theta equals a, which is 3, and we decided it was sine, times the sine of b, which is 2, times theta, plus 3. That's your equation. Okay, we good with that? You see how these transformations are the same. We got some different names, but it's the same thing happening. They look kind of different, periodic graph, but yeah. You don't need to. Are you asking me to do that? Oh, okay. Sorry, you don't have to, but yes, I will. So f of theta equals a times the sine of b theta plus d. That's what we did. Which again is literally the same stuff. Let me just find out how to write it. I could write this as f of x. No, well, yeah. Let me call it g of x. G of x equals a times f of b times x plus d. That's the generic, where I don't even have a specific function in there, but it is the same stuff. Whether this was x squared or whatever, it's the same things there, okay? So that's what I want you to connect that to. If this was quadratic, I would have, let me just use h, yes, x equals a times, I guess in this case, it would just be bx squared plus d, because we don't have a speed there yet. But you see, it's the same thing no matter what it is. Cosine right there? Mm-hmm. So, all right, we all good on that? Okay. Look at this. We've got the period amplitude. Okay, so I'm going to draw in my midline. I know it doesn't ask me for it, but that helps you with other things, right? So what do you think the amplitude is here? 2, because here or here, but not there. Amplitude is 2. We agree with that? So I can eliminate those 2. Then the period, so if I start at 0, I'm going to go from here to here, right? And what's the period? Pi, okay, which makes it a. Now, what if I said that we're going to make this, we're not shifting left or right still. The amplitude is 2, but what is the a value? Is it 2 or is it negative 2? Negative 2, because the sine function looks like this, right? And if I start here and go down first, then this has been reflected in the x-axis, right? Which makes the a value negative, but the amplitude is still 2 no matter what. So the amplitude doesn't change no matter whether I shift it or do whatever. If we haven't shifted left or right, yes. But I don't know for sure that I haven't shifted left or right because it didn't ask me anything about this. But I mean, it could have been a cosine. It could be cosine that goes from here to here and we shifted to the left. I'm just saying if we haven't shifted left or right, it has to be a sine and it has to be a reflection, okay? Or it could be a sine that starts here and goes to here but was shifted left, right? But since we hadn't talked about shifts yet, that's why I said, if we know, which we don't, but I'm just saying let's pretend, if we hadn't shifted left or right, it has to be sine and it has to be a reflection, okay? We good on that? What questions you got? Okay. All right. So function k has a maximum at this point. After this maximum, the next minimum, that makes a difference. We have an infinite number of maximums and an infinite number of minimums, right? So if I have a maximum, I need to know whether or not it's the next minimum or things could change. And it gives me this point. So it's which of the following could be an expression. We had one similar to this the other day. They weren't asking us for equations, but it was similar to this. We're going to need to sketch something. And it's not going to be perfect. We don't even care. Like, I'm not even going to try because there's still no way without graph paper that I can make this look decent. So I just need something up here to wrap my mind around. All right, so my first point is at 0, 6. Okay, this is at 6. Here's my point. Then that's the maximum. Next minimum that I come to is at pi halves, negative 4. Again, don't really care if it's to scale. I mean, you can sort of try, but it's not really going to help you any. And then this point is here. Okay. All right, so now if this was, I have answer choices here, and they all say cosine. But if some of them are cosine and some of them were sine, I would need to also look at shifts, which again, we're not even there yet. Or I would need to make sure I knew what the parent function looked like, right? Like, you know, cosine looks like this, right? So if cosine looks like that, and I haven't shifted left or right, then when I put this in here, how much of the cycle do I have right here? Half the period. So I have half the cycle, which is half the period, which means the entire period is what? Pi. Since this is just half of it, right? I would just double that. That's how I know the whole period because that's only half of it. Because you go from a maximum to a minimum, that's halfway, right? Remember, everything's half, half, half. All right, now, I could figure out without them telling me, which they basically told me because of the answer choices, where my midline is. That midline is at 1. So if I draw that in, clearly not to scale again, don't really care, but that helps me get the A value. What's my A value? 5. My A value is my amplitude. It's 5 because I'm going from 1 to 6. Does that make sense to you? So that means that eliminates A and B. Okay. So I know it's one of these two. And again, I do the same on all of them anyway. I don't want to eliminate this just because we haven't seen one that has a pi in there, because you could have a pi in there, absolutely. But that's what the period is. B is what I want. That's 2 pi divided by the period, which gives me 2. This is the B value, so my answer is D. Okay. On every single one of these, and actually on most everything you do, take it a piece at a time. Don't try and do it all at once and look at it all at once, because there's a lot going on, and especially when it's new to you and you're not that familiar with it yet, it can seem a little overwhelming, but just a piece at a time and eliminate some things and figure out what you know, okay? We good so far? Awesome. All right, grab your next piece of paper. This is also going on page 4. I'm going to give you a second. I don't have enough time to finish the whole thing, and that's okay, but I want you to think about it at least, but I don't have to rush through the rest. I want you to read this one, look at the answer choices, see if maybe you can at least eliminate something before I start talking about it together. Okay, I know that might not have been enough time, probably not, but that's okay. Even though it doesn't ask you to, and you don't have to, I highly suggest you actually write these things down so that you don't accidentally pick the wrong thing off the equation when you're just looking at stuff, okay? So it's good to write them down to make sure that you've thought through it correctly. Then again, the first thing that I always do is the midline. So this is telling me, like, I can draw in where the midlines are, but this one's telling me it's supposed to be at -1. So if I put this one in here, I can see that A, this is no good. On C, if I put in that looks pretty good. Same with D. and same with B. Okay. Then the other easiest thing, I think, is the amplitude. And all three of my remaining choices all have an amplitude of 3. That's not going to really do much for me. But then I had my B is 2. From that, I need to know that the period is pi. So if I start here and I go, whoop, dang it, 1 cycle, that gets me to 2 pi. So I don't like B. If I start here, go through 1 cycle, gets me to pi halves, I don't like D. So I'm really hoping I like C, or I'm going to have to start all over. So I start here, go through here, that gets me to pi. So this has all the pieces I like. My answer is C. So you can do those little things in whatever order makes the most sense to you, or depending on the question, maybe something's more obvious that you can eliminate or whatever, but be careful just willy-nilly eliminating things as well. Okay, we good? Okay, so let's talk about phase shifts. So phase shift of a sinusoidal function sounds all fancy. All this is your horizontal translation. I'm going to abbreviate that. There's not enough room. The horizontal translation of a sinusoidal function is called a phase shift. So everything just has a different name, but it still works the exact same way. But there's a little asterisk on that right now because they give me this, which again, it's nice that they give me the generic stuff. But every teacher that I have encountered where we've had discussions on this, whether it be online or in person or on Zoom, and every teacher I have ever met and every textbook I have ever seen teaches horizontal translations by making this x minus c. And this is x plus c. Now, it works the same way. X being a whole 9 yards, if we have the equation, that's phenomenal. However, it seems that they're trying to simplify some of these questions by just asking you for A, B, C, and D, and just asking you for C. If you're not paying attention to how this is written and you're doing what you've been taught for years, you can get this signed, S-I-G-N, wrong on that. And so I'm going to explain to you what I mean, and then we're going to just be really careful with this because I have this bad feeling now that I actually messed it up in second period. I've been thinking about it all day. Not this, but one of the questions at the end. So let me just explain to you what I'm saying here. If we were doing quadratics, okay, square, we know that that's a horizontal translation, right? Without a question. Do we go left or right? Left, okay? So we go left. Before we ever saw this, and we're talking about this stuff, because our generic equation like this would have had x minus c in it. If I asked you what is the c value, your answer would be -3, because we're going to the left 3. Does that make sense? If this equation is actually a positive 3, you see the difference there? Because this says x plus c. It's just a matter of you matching this with this and using the letter correctly. It only seems to happen with trig stuff. I don't know why. I'm not happy with it, and I'm not the only one, but College Board seems to think this is a good idea. I feel like we're throwing a little bit of confusion that is unnecessary into something that's brand new, so we're just going to have to be careful, and I'm just going to point it out every time, and we're going to be really, really careful with our C. Okay, but again, the good news is they should write something like this so you know what to look at, but we just have to think a little harder on this one for absolutely no good reason, in my opinion. It's everything that I have seen as far as trig is concerned, yes, they are consistent in what they're giving you. Like they're not changing that up to make it confusing. I don't think it's a gotcha. I don't know why, but it should be the same every time in the trig stuff. Yes. Did you have a question? Exactly. Yes. It's still left or right, just like it has been before. That's why instead of like if this said x minus c, and this would say then we phase shift by positive c units, and that's the way we've looked at it before. But since it says plus c, now it says by negative c units. I don't know, but again, I'm just pointing that out. I'm not trying to make it more complicated. I don't like it. We all sort of complained about it, but nobody's listening, and I don't even know if I got to the people that it matters, but. Mhm. Mm-hmm. Which means we go to the left 4, so left, but the C would be 4. And we're going to look at those. Don't worry, we'll so necessary, so we can try and wrap our mind around that. Okay, because it's something that, again, it's just not necessary. Now we're gonna do example 7 and come back to 6, because I feel like 7 is a better starting place than 6 is with this stuff. So flip it over and then we'll flip it back. All right, so the figure shows the graph of a trigonometric function h. Which of the following could be an expression for h of x? So just like the rest of them, well, actually, I could go ahead and look at my answer choices. I mean, look, all the D's are the same, right? So but I'm just sketching it anyway. Plus, it was kind of already there, so I didn't even have to try and figure it out. Now, looking at your answer choices first are good. You don't always have to pull everything out, but look what happens. All of these are the same. All of the A's are the same, and all of the B values are the same. The only thing that changes is the C value, all right? And so all we have to look at on this one is the shift. Now, if this is x minus pi fourths, which direction do I go in? To the right. Okay. And all of these are minus, so we're going to the right on all of these. Okay. And C would be negative pi fourths and negative pi. Okay. Well, we're going to actually write them down on another one where they change up, but that's what we would have there. Okay. So when I'm looking at these, I have choices between sine and cosine, which now, because I'm shifting, the way I think the way to look at these things is, where do you actually start the parent function? So since we start with cosine, this is what cosine looks like, right? And none of these have a reflection in them, so we don't have to worry about that yet. So if I am starting on cosine, before I shift left or right, I am going to start up from the midline, whatever A is, in this case 2. So basically, here's my midline. I would start right here, this one, okay? Right here, but then I'm supposed to shift to the right pi fourths. When I do, I end up right here. Is that even touching my graph? No, then that can't be the right one. You with me on that? Pi fourths is not labeled, but should I know where it is? Because it's half a pi halves. Yeah, like we need to know those things. So I don't like A. All right, so again, I'm starting here, but I'm supposed to move to the right pi. Totally not where my graph starts, right? So I don't like that one either. Because these are sine, before I shift, I start on the y-axis at the midline, so right where we start. Then we're going to shift to the right pi fourths. Look, I'm touching my graph, okay? Doesn't automatically mean my answer. That's my answer, but it's touching my graph. Then when I touch my graph, then when I go sine, boom, there we go. That looks pretty good. Because the periods were all the same, so I don't have to worry about that. So I think I like C. Let's check D. Sine starts here. I'm going to move to the right pi. Clearly not where my graph starts, right? Which means my answer definitely is C. Okay, what are we confused about? Because this is cosine and this is sine, so I'm starting at different places. That's why. Yeah. Okay, good question. What else you got? So let's go back and look at that. On A, for A, I started for A. So when I moved to the right pi fourths, I ended up here. For C, I started right here. So when I moved to the right pi fourths, I ended up there, because they're different graphs that have different shapes. Okay? Does that make sense? We good on that? Beautiful. Now, flip back to 6. All right, so the first thing we're going to do is not even look at what the question's asking. We're just going to look at the answer choices so we can talk about the C values here. So this one here, A, doesn't even have a C value, right? So C equals 0. That's pretty easy. Look at B. First of all, on B, am I going left or right? Right. I'm going to the right. And my C value, based on what they set up there, C would be what? Negative pi. Very good. We're going to the right, but our C value is negative pi. Remember, X is just a hot mess. He's a liar. He's confused. I don't know. All right, so then on C, are we going left or right? And the C value is 2. On D, we're going which way? And my C value is negative 3 pi over 2. Okay. Now, this question didn't ask me for that. All I really need is going left or right for the question, but again, I wanted to talk about that because you totally can't just be asked what are A, B, and C. Okay? We okay with that? All right. So now let's actually look at the question. All right. Which of the following could be an expression? All righty. So let's start with the cosine ones. Now notice these, all the A values are the same, right? Or are they? No. The amplitudes are the same, but the A values are different because some of them are negative, right? Then my D, the midline, is all the same, so I don't have to figure out what that is. There we go. And then there is no B value. All right, so that negative is going to make a difference. Let's start with the cosines again. So cosine starts here. When I start up from the midline. Unless it's a reflection, then I would start down from the midline because it would have reflected, right? So I'm here. I'm going to start up here, 3 up, not at 3, but 3 up from there. And C is 0. I don't move left or right, so I'm thinking A makes no sense. Would you agree with that? Okay. If this was -3, I'd be golden, but it's not. All right, so now on B, this is a -3. So instead of starting up from the midline, I start down, and then I move to the right pi, because I put myself an arrow so I don't mess things up. And then this is not touching my graph, so I don't like it. Okay. Then I'm going to look at sine. So this is what my sine function looks like. I start on the y-axis at the midline. This, then, I'm supposed to go to the left pi halves. Well, that's problematic because I don't have that on there. But I don't have to start here, okay? So watch this. I have, do what? Oh boy, it's not that bad, I promise. So there's one cycle, here's 2 cycles, right? Because these are periodic functions, whether I start here and move left or right, I can also start here and move left or right. Yes? Does that make sense? And so since it's going to go off the graph, if I start here, let me just start here because then it just starts over the same. Now, for the parent function, this is pi, right? You've got to make sure you know what it is for this function. What is the period here? 2 pi. Okay. Now, even though we know it's not a cosine, it's not one of these cosine ones, I can still look at it as an upside down cosine. I start here, end here before I start back over, right? So 2 pi, which means just like I was starting here at 0, instead of starting here at 0, I can start here at 2 pi, right here, and then do this. I'm going to do the left pi halves, and I'm touching my graph, but this is a positive. So shouldn't I go up like this? Because that's what I go over right here, right? So I don't think I like C. I have a question mark there. I don't think I like it. But then if I look at this one here, since I'm going to the right, I can start back over here. Or I can start over here. It really doesn't matter, but it's easier to count from 0 if you can. So I'm going to start here. I'm going to move to the right 3 pi halves, which is right here, which isn't that just where I was? It's just getting there a different way, right? Right here. But since this is a negative, that means I have a reflection, so I go like this, and this is my answer. You see how that works? Now, do you see why I'm telling you? You have to practice. You can't look at one of these and be like, I got it. Just like with the unit circle stuff, if you practice these, they're going to make more and more sense to you, I promise. You just got to let it soak in and not avoid it, because that would be bad, real bad. Okay? We all good on that? Yes? Okay. All right, so this next one, in the next 5 minutes, I don't want to rush this one in 5 minutes. So we will start tomorrow. I'm going to go ahead and give you your assignment so that you have it. But this one, we'll start here tomorrow and then work on this, okay? There are, but they'll look like this, and so you can just not do them yet, okay? Let me see if I can pause this thing now. Oh, see? Oh, I didn't have that. Hang on a second. I figured this out. Hang on just a second. Alt, Shift.